Hello everyone, today we are diving into something really exciting, how to create random procedural content generation for spline meshes. It doesn't matter if you're crafting roads, rivers or dynamic pathways, PCG is really great for adding dynamic random feel to every object that you generate. In the current version of the engine 5.5, you cannot natively add randomization to the spline meshes that support curving for the mesh. So you can add this functionality by combining this with the post-process function, and you can achieve very high end level effects with this. So let me walk through the example that I created here. You can see that the first spline has just a single mesh, which is the native support of the current spline mesh placing with PCG. And the second one has a function in the blueprint that generates random amount of this second mesh that we entered here, this random mesh. And this can also be an array of meshes, so you can add multiple ones and just pick random of them. And you can enter the percentage of the random elements that you want to have. If I enter 100, you can see all of the meshes are the random mesh, and I added a start mesh and an end mesh, which you can place at the beginning and the end of your spline. So let me walk through how this example is created. It's really not that hard. It's just an extra step from PCG to control after you have generated the spline to swap the meshes with your variables in your blueprint. So in my level, I have a blueprint that I'm using for this example, which you can see it's the same blueprint as before. This is the random mesh, we can give it percentage and so on. So the same blueprint. And the PCG graph attached to this blueprint. Let's start first with the PCG graph because it's very simple. So here is the PCG graph. All of these calculations here you can skip if you just want to enter the distance yourself. This calculating the size of the mesh. So if you don't want to do this calculation, your graph can look just like this. So 5 nodes. First you're getting the spline data, then you're sampling based on the distance. In my case it's 70 units. That's the size of the curve that I'm using for the example. Then you're creating the spline with these new points every 70 centimeters. And for this spline, you're adding the mesh as a variable from the input mesh in your blueprint. So this getActor property. This main mesh is the variable name in my blueprint, and I'm outputting it into the main mesh variable. Here I'm adding this attribute to my data and again outputting into the main mesh variable, and into this spawn spline mesh I'm overwriting the static mesh with this main mesh variable. So this is everything you need to do in your blueprint to achieve the example you have here with the single mesh. And this is all the support that you get from this PCG graph just for a single mesh overwrite into this static mesh. To be able to place random meshes, you'll need to call a function in your blueprint. So I have this swap mesh function in my post-process functions call here. So in this spawn spline mesh node, you can call a function in your blueprint. You just enter the name here. You click on the add element and enter the name into the field. And if we go to the blueprint right now, you can see that in my blueprint, I have a spline component. Let me go to the viewport. So I have this spline component. I have the PCG component. My PCG graph is connected here into the PCG graph property into my PCG component. And I have all the variables here that I want to be able to enter into my blueprint. So main mesh for my PCG graph, then the random mesh that I want to have a random amount of the percentage that I want to add this mesh, and the start and the end mesh for the first and the last element of my graph. And I have a function created, which we are calling from our PCG graph. So click on the add function button here, create the function, and it's very important that this function needs to be marked here into the details panel as co-in editor, and also it should not have any inputs right here. So if I add an input to this function, let's compile now and save this. If I go back to my PCG graph, you can see a warning here that the function in my class has incorrect parameters. This is because the function should not have any inputs. So let me delete this. And also, if I remove this co-in editor tick, let me compile and go back here, I have a warning again that the function requires co-in editor to be true. So let me enable it back. And if I compile and save this, I have no longer any error into my PCG graph. So this is the way that you know that this function is configured correctly. If you open the function then, it maybe seems a little bit complicated, but it really isn't. Let me go step by step into this function. So first, you are getting all the components by class. So your PCG graph, when you drag it into the level, let me select one, and here into the right panel, you can see that the PCG graph is creating a lot of spline mesh components. For each brick that it's placing here into this curve, it's creating a spline mesh component. It's calculating the position of this component, the tangents for the current PCG spline mesh, so they are curved correctly based on the previous and the next one. So you have a set of PCG spline mesh components. So if I go back to the function, you are getting all of these spline mesh components, and then you're doing a for each loop through all of them. Into the loop body, you're executing this code for each element in your spline mesh, in your PCG graph. So let's check what we are executing. So first we set a local variable, which is this spline mesh component variable. We are setting it with the current spline mesh through the array. So we start with the first one, then the next time it executes, it will be the second, and so on. We are setting the current reference to the spline mesh. Then we are checking if this is the first element in our array, and I'll show you later how this is created and explain what is the math here. But the important thing is that we are checking if we have entered a start mesh and if this is the first element into our graph, and if it is, then we are choosing this spline mesh component and we are setting the static mesh with this start mesh. We are doing the same for the end mesh, and then for all the rest, we are picking either the random mesh right here or the main mesh that we have entered. And for the random mesh, we are just checking if a random integer to 100 is smaller than our random percentage. So if we entered 20%, for example, chance, we are generating here a random number, for example, 35. It will not be greater than 20, so we will not execute this random mesh placement. We will go here at the regular mesh placement. And you can completely skip this step here. You'll just leave the regular mesh untouched. So by default, the PCG will just place the regular mesh. But because I'm running this script to place the first and the end mesh manually by clicking the button into my level, I sometimes rerun the script a couple of times and I'm just repopulating random meshes. That's why I just like to reset the regular mesh anyway for the all the elements that I don't want to place the random mesh. And this is saving me from getting too much of my random mesh setup. So let's compile and save this. And let me go back to the level again. Let me show you that if I execute this swap mesh node, it's properly taking my start mesh, my end mesh here, and I'm placing a random mesh with this drain hole in the middle around 50% of the time. So if I reduce this to 0, and you can see I'm just using the first and the last mesh and no random mesh is added. So if you like this, I'll now show you how you can build it from the ground up. So I did a quick overview, so you know what we are doing, but let's now do it all together, so you see each step of the creation process. So let's create a blueprint class. It will be an actor type blueprint. Let's call it BP Spline Random Tutorial. Let's go inside this blueprint, and inside this blueprint I'll create the variables that I'll use. So they will be static mesh type. I'll have main mesh. I'll have random mesh. Then start mesh, end mesh, and a random percentage. And I'll choose the percentage variable to be a float value. I'll move it under the random mesh, so they're aligned better in my details panel. And I'll mark the eye icon for all of them because I want to be able to set them into my level. Let's create a function and we'll call this function swap mesh. Let's mark this call in editor, make sure you have no inputs, compile and save this. Now let's add a spline component into our blueprint. Let's add a PCG component into our blueprint. And for this PCG, we need to create a graph here to be connected into the details panel. So let's go back into our content browser here. Let's right click, search for PCG and add a PCG graph. Let's call it PCG Spline Random Tutorial. And this PCG graph, I'll just get spline data, then I'll sample the spline with a spline sampler. I'll use a distance and I'll set the distance to 70. Again, you can create a variable. So let's do it this way for the tutorial. Let's go back to the blueprint. Let's add a variable with a type float and let's call it distance. Let's move it under the main mesh. Let's make it public. Let's compile and save. And now into our PCG graph, let's get actor property. We'll get the distance property and we'll connect it here into the spline sampler distance increment. So let's minimize this and make sure that this mode is set to distance, that your distance variable is connected to the distance increment. So this will create PCG points each 70 units that you created for your distance component. Let me go back here and add a default value for the distance of 70. So compile and save this. So now back into our PCG graph, let's create spline. This spline is now each 70 units of our original spline. And let's spawn spline mesh with our main mesh selected. So we need to get the actor property for our main mesh. So copy this get actor property, type main mesh here. We need to add this attribute to our data. So add attribute. connect this main mesh here. Let's output this attribute to the main mesh, connect it back to the spline mesh, and here at the end of our properties here, let's use this main mesh attribute and output it to the static mesh of our PCG graph. So let's save this. Let's go back into our blueprint, choose the PCG graph node, and let's drag this newly created PCG into the graph variable here. Let's compile and save this. And right now, if we place this newly created blueprint into our level, we can then connect some mesh to our variable here. Let's make it a little bit more interesting. So we have a curve here, so you know it's a spline mesh, not a regular mesh placement. So right now we are properly placing a spline mesh into our level. Let's use now our post-process function to add the random meshes into our graph. So go back into our PCG graph, select the spawn spline mesh, and here into the post-process function, let's add one function call, and let's call the swap mesh function. Let's save this. And now, if we go to our blueprint, let's go into our swap mesh function. And let's, for example, print a string, and this string will be swap mesh code. So let's compile and save this. And right now, if I open my output walk, if I clear the walk, and if I move this point, if I open the walk, you can see that this swap mesh was called. So we are properly calling our function. You can see that we have a lot of warning nodes here as well. This is because our default scene root is not static. If you want to go to get rid of these warnings, go into your blueprint, choose the default scene root and set it as a static mobility. So let's compile and save this. And let's now work on the blueprint function that we are calling. So right now, let's get components by class. We'll get components of class spline mesh component. And for all of these components that we get here, we'll do a for each loop. So for every component, we'll first check if this random mesh is set up into our level. So let's control drag our random mesh. Let's check if it is valid. We'll add a branch node by hitting B and by holding B and clicking into our graph. So if we have a random mesh setup, and also we want our random float in range, and the range will be from 0 to 100. Let's check if this float is smaller than the random mesh percentage that we set up. So control drag our random percentage here. So if we have a valid mesh entered, and if the percentage value is smaller than the percentage that we entered, then we know that we want to swap our mesh. So let's first create a local variable here, which we'll use for the spline mesh. Let's do the type spline mesh component. Let's set this spline mesh component variable to the current spline mesh into our array. And let's use this spline mesh and set the static mesh. And we'll set the static mesh to our random mesh. So let's compile and save this. And if I go back to my level, if I select my blueprint, we have this random mesh variable here. I can put a random mesh here and enter a percentage, for example, of 50, and you can see that we now start to get random meshes into our PCG graph. So this is great, but you can add additional functionality, like enter whatever logic you want. So for example, you can have every second element to be this random element or something like this. But what I've come up with for this example is to add the first and the last element to be in this start mesh and this end mesh. So let's go back into our graph and see how we can do this. So let's first check. We'll move down this and we'll first check if our current index is the first or the last one. So we'll do a modulo operator, which is this %sign operator here. We'll do a modulo operator by the length of our array with components. So this is the total number of pieces of meshes that we have into our PCG spline mesh. And if we are having this modulo operator dividing our current index to the length of our array, if it's returning 0, this means that we are currently at the first element. So let's do a branch node and check if this is equal to 0. We will also want to check if our start mesh is valid. So if both of these conditions are true, let's do an AND Boolean operator. If both of these conditions are true, we'll set our spline mesh, static mesh variable here to our start mesh. If not, we'll do another branch. We'll check if our AND mesh is valid. So let's drag our AND mesh here. We'll check if it's valid. Then we'll check if our index with a modulo operator, and this time we'll check not the length but the length -1. So this will be our last element. If this is equal to 0, and this means that this is our last element, and we'll set the static mesh to this last element, and mesh element, and we'll reconnect back our logic here for our random element into the false statement here. Let's compile and save this. And right now, if I mark my PCG graph, if I click this swap mesh button, you can see the first and the last element are set up properly. But you can see that every time I click on this swap mesh, I'm doing more and more of this random element, no matter that I have set up this percentage at 50. So this is because every time we are randomly assigning new and new of this random element, and we are not setting back our original mesh. So I'll set up our original mesh here into our false statement for the random mesh. So I'll connect the main mesh here. Let's compile and save this. And right now, if I choose this blueprint and click on this swap mesh, I have properly set up the first and the last mesh, and I'm always getting the proper percentage of the random mesh. So now it's around 10% chance to have a random mesh. If I have it at 80, almost all of my meshes will be this random mesh. If I have it 100, all of them will be, and 0, none of them. But I still have the start and the end mesh, unless I disconnect some of my meshes, and then I'm just getting our original mesh. So like our default behavior. This is how you can get random meshes into your spline mesh components created by PCG. I believe that this is very powerful approach. So guys, please, if you like this tutorial, if you learned something, please like my video, subscribe to the channel. You can join the channel so you can watch the videos earlier. And I'll see you in the next tutorial. Bye guys.